Hello, everybody. So, today is going to be our third lecture on the cloud service from scratch series that we have started. And today we are going to get a deeper dive into the tool analysis and how these tools actually get integrated together to form a cloud service. Majorly, we're going to expand on the cloud architecture that we have discussed so far. I know it may be a little bit boring for you guys to go into the theoretical side, but hopefully we're getting closer to the technical aspects as today we are going to discuss about the tools that are relevant to the architecture that we are going to use and why we are going to use it. That's what we are going to discuss today. So let's dive a little bit deeper. So we have discussed so far, like I think that you got the basic idea that we have. Like we have two backends in our backend. Majorly, I would say three backend APIs that we have in total in this cloud service architecture. And then we have the front end, and then we have all of this extra things as well, like the shared volume and all of this stuff. So let's go a little bit deeper on how we can actually like divide these aspects and what tools are we going to use and why we are going to use them. So first of all, let's talk about our backend middleware API. This part right here. We're going to discuss about this part. So for this, what we are going to majorly use or think about using is Python. Let me just talk about why we are going to use Python for this. So Python has a tremendous amount of libraries, and we what we really want is to keep our architecture and our tools very simple to our needs, right? So that's why we don't want to use multiple different types of frameworks. For example, if we have a couple of libraries for like controlling the system within the system, for example, in our system APIs that we have talked about earlier, we are definitely going to use Python for this. Why Python again? Because we have tremendous amount of libraries, utilities for like having GPU utilities and similar stuff like even Docker SDK and all of the stuff. We have a very tremendous amount of like libraries out there that we can use for our like system oriented libraries. That's why Python is the best use case for this. And also the syntax is very simple, and also the language is also itself very simple. So that's why I prefer having a one tool stack for the backend, and that we can expand on like adding on libraries and stuff. It makes our project building a lot easier. So we are going to use Python. We're going to use Fast API for the server. We're going to use the Dramatic for for the task use, WebSockets for real-time communication. We're going to use like GraphQL this time. It's on you what you want to do. Like the major difference between REST APIs and GraphQL is like GraphQL can actually provide you the exact amount of data that you need. It actually provides very much a low latency feature that you don't need to have a huge amount of latency. It can actually reduce the number of APIs as well because you only have two APIs, mutations and queries. From both you can from mutations are like in REST APIs like post, put, like these type of requests. So you can actually just merge them down into mutations, and actually provides a lot of ease as well for handling those set of APIs. And then we have the SQL Alchemy. SQL Alchemy is used for the entities. Um, and then we are going to use Alembic as well. Alembic is used for data migrations. And then we have, I think that this is pretty much it. And you can also use Pydantic as well. Like Python is not a typed language, so you we can use Pydantic to enforce types into it. It can actually make our code a lot more readable, I would say. And then let's talk about the let's talk about the system backend that is going to be used within the system itself. And also we are going to use like Postgres as well here. Like we are going to use Postgres, we are going to use like all of this stuff here. And if we talk about the backend system now, and also we are going to use Redis here as well. If we talk about Redis, we're going to use Redis here as well for caching. So Python fast API, dramatic for like for the task use, WebSockets for real-time communication, GraphQL, SQL Alchemy, Alembic, Pydantic, Postgres, Redis for caching. And then for this, we are going to use Python, all of this stuff. And we are not going to use SQL Alchemy or Alembic or anything like that, but we are going to use Pydantic because this is not going to be this backend is not going to be focusing on storing data because we need our data to be stored in our middleware API, right? So in here we are going to use the Docker SDK. It's optional. I will show you why it's optional. And also we are going to use Sentry here as well. Sentry is going to be used for error handling. Any error that is going to be reported is going to be like stored in Sentry. So we can use the Sentry platform to like see the error logs there. It actually provides us a lot of ease on what APIs are actually failing, and we can actually get logs from there as well, right? And and jobs as well. We need jobs to be there as well. The fast API native jobs that we need. We need those jobs. I will discuss about these jobs in later on in our discussion. And then we are going to discuss about the. Let me just write it down here. We are going to discuss about the environment. Environment specifically, I'm talking about the Ubuntu environment, right? Why do we need to talk about the Ubuntu environment? That's actually the first question I think so that is going to come into your mind right now. So the thing is, this cloud service specifically made for AI-based models, right? So in order to compensate those things, we need to provide the environment for the AI models as well. And let's talk about the environment. First of all, we need to have NVIDIA because we are actually operating on NVIDIA right now. We need to have NVIDIA CUDA environment. We need to have this properly installed. And then we need to like allow the Docker containers to access to NVIDIA GPUs, right? We need the Docker containers to have access. So for that, we need to install NVIDIA Container Toolkit. And then we are going to install Cloudflare. Cloudflare, as I mentioned before, is going to be used for reverse proxy. Allow the local running URLs, for example, localhost 4245, whatever the localhost URL is running, we need those URLs to be exposed. Even if you deploy a model and that model is running on some kind of port like 2001, we need that AI model to be exposed to public via Cloudflare, right? So we use Cloudflare for these type of things. And then we are going to use some services like service system CTL services or whatever services that you want to call them that you have supported in your Ubuntu environment. We need the services for different type of checks. Those checks are going to be regarding. Let me just here. Those checks can be for updates because if we want to send some updates to the system, we can actually use this. We can use these checks. And for second, for like we can discuss about service handlers, right? Service handlers. For example, if something goes wrong with our like system APIs, we can have this service running in the background that can check if the system API service is running fine or not. It can restart the service. It can kill the service if it gets stuck. All of these checks can be vetted into this service handler. So we don't have to manually check the system. We have an automated service that is running in the background that is checking all of these things, right? And then we have then we want to mount the shared volume, that we have, the NAS server that we have, that we discussed in the previous meeting. We want that to be mounted, and we need to have some set of commands to actually mount that shared volume. And also we need to mount the partition as well. And I would recommend using an XFS file system in when you're installing the Ubuntu system. Do use the XFS file system for that, and do try to partition it early on when you're installing Ubuntu, because we need that partition uh, to be mounted later on for our own like use cases. And then we want our backends to be exposed. We want our exposed Docker API URL, and we want our system backend to be exposed as well, right? We want both of these backends to be exposed. So these are three major things regarding the backend and the environment. Then we already know regarding the front end. Um, in front end, what I am going to majorly prefer is using React.js, Next.js, Redux, and Oath. That's what I am going to majorly be referring to. And also primary at as well. Primary at is going to be a very useful library for providing us predefined components. So it will make our front end more easier to use, and we don't have to build our own components again and again because we already have the predefined components there. It's a very much useful library for me that I preferably use. So these are going to be the things that we're going to use. And I think that the question that is going to be coming into your mind right now is, why did I declare this Docker SDK to be optional, right? Because obviously we're going to use Docker for deploying our AI models, right? Because we don't, as I said in the earlier meetings, Docker is going to be very much essential. But why are we not using the Docker Python SDK? The thing is, if we actually go with the Python Docker SDK, we have to build each and every API for that functionality. Like we have to manually develop APIs for this functionality, for every functionality, Docker related functionality, right? We don't want to do that, because the thing is, Docker actually Docker provides us with Docker Engine API. We can actually expose this Docker Engine API with Cloudflare. So this will allow us to control the Docker of a particular system using APIs rather than creating each and every API and then controlling it. We have saved a lot of time by using just the Docker Engine API and exposing it via Cloudflare. So it's saved like 50-60% of our time in development phase, right? And this is the Docker Engine API that I was talking about in the architecture in the earlier meeting as well. So we are actually following the same thing right now. So this is the whole thing. And similar to this, we can actually use the Cloudflare APIs as well. Cloudflare also provided us an SDK and also Cloudflare set of APIs as well. So I hope so you can actually get the whole thing that we are talking about, and you actually get a lot deeper analysis in why we are using the tools and what tools that we are using. And And also, if you like the videos, do like subscribe to my channel, and also like and subscribe. And also, if you have any suggestions in improving these videos, do comment those down into the comment section. It would provide me a lot of help. So see you guys next time. Take care, guys. Bye.